Welcome. This is the video I'm going to talk about number 7 and 10. I wanted you to see some of the work. Again, I apologize about the ducks in the background. They're ready for breakfast. But here on the screen, I've got the two graphs that you should have. I just found digital version so you guys could read it well. For that awkward cut, I had to pause and sneeze. So what you're seeing on the screen, here's our endothermic graph. So I didn't ask you to label the activation energy, but I did ask you to label the reactants, the products, and the delta H. So here we've got our endothermic graph. Again, remember what's happening in an endothermic graph. Energy is coming into the system. So we should see that the graph finishes above the reactants line. So we've got more energy in our products than we have in our reactants. So think about what that means for the products. If we've got more energy in the products, you know from Biology 1 and the things that we've talked about that chemicals store energy in their bonds. So either we're making more bonds to store more energy, or we're making stronger bonds. So maybe we're making double bonds, maybe we're making triple bonds. Somehow, some way, the molecules store more energy in an endothermic reaction than an exothermic reaction. Let me say that differently. I said that poorly. The products store more energy than the reactants in an endothermic reaction. It's kind of hard to compare one reaction to another. Moving down to the exothermic graph, same kind of things that I'll point out, but this time the reactants are higher than the products, so we've lost energy. Makes sense. It's an exothermic reaction, so we're going to lose energy. Make sure you see the labels on the axes, potential energy in kilojoules and reaction pathway on the Y. So moving on to number 10. Number 10 seemed really hard. Freely admit it, when I read it on the screen, seems tough. It's really not. It's really a pretty basic stoic problem, and then just making the units match. You see in that top box there, I took the mass that I was given in metric tons, which is this weird unit we've never seen before, but who cares? Doesn't matter we've never seen it before, because we've got a conversion factor to get to something we have seen before. That's what's great about stoic. I don't even have to know what this mess is. I just have to know that it's 1. And I know that I recognize this kilogram. I don't know what a metric ton is. Who cares what a metric ton is? It cancels out. I know what a kilogram is. I know what a gram is. I know what a mole is. So stoic gives me the ability to get out of this mess that I can't do anything with, because it's in English measurements. I can't do anything with it. I don't know any conversion factors except for this one. Thank goodness I can get to metric, and I can do a bunch once I get to metric. So that gives me my number of moles of water in the iceberg. Then the last conversion factor is just to multiply in the heat capacity that was given in the question. Again, make my units right, cancel the moles, I'm in kilojoules. That's how much energy it would take to melt that iceberg, which is a crazy amount of energy. Like that would not be a viable solution, because we'd have to put so much carbon dioxide into the air to melt that, because we got to make electricity somehow. It just wouldn't be efficient. So that's numbers 7 and 10. There will be one, hopefully you've already watched one video about all the multiple choicey types of answers, and hopefully you have seen the intro video that explains what you should do for all of today. If you haven't seen all 3 of those videos, please make sure you do that.